Hey guys, what's up? Eddie Alho here with KissAnalog.com. Today, what we're going to do is we're going to take a look at this Kaiweets power supply. It's a 30 volt, 10 amp power supply. Pretty cool. Under $100 on Amazon. I'll put a link down below. They sent this to me for free so I could review it. That was pretty awesome. No strings attached, anything like that. Not really a sponsored video, not being paid to do this. They just gave me power supply. Just looking at the specs, I actually looked into it before I agreed to have them send it, and it looked like a nice one. It looked, compared to other power supplies I saw on Amazon, I thought, yeah, this looks like something worth looking at. So here it is. Let's open it up, take a look at it, okay? What we're going to do is I'm going to look at the voltage and ripple on the output, with the load on it, of course, and no load. We'll look at the ripple both ways, okay? And then what we'll do is we'll pull some current. Okay, wow. It's funny how sometimes you don't get manuals these days. Now, it does have the CE, and I do understand a lot of people don't trust that at all, because that CE mark is a self-certification. Okay, it's just a few pages kind of showing how to set up. It's a power supply. It's not programmable or anything like that. That's actually quite a lot of watts. So just talking about the price of this thing. Okay, it looks like it's packaged very nicely actually as I'm opening this up. It has, this is a US cord. Pretty typical what we see here. And got some leads. Now, this thing's rated at 10 amps. I'm kind of curious if these guys are going to carry 10 amps without dropping much voltage. We'll find out. They actually kind of look a little bit questionable for 10 amps, let's say that. I think they're 32 inches long, if I remember the spec, something like that. Wow, this guy, holy smokes, this guy's in there. Okay. It's one of these clamshell things. That is nicely packaged. Packaging, good packaging actually is an art. Okay, wow, this thing is super light. Obviously a switching power supply, not a big linear like these guys, very heavy. This guy is, this guy's a switcher for sure. It's so light. Well, and that's also how they can make them inexpensive. I can see right through the plastic, through the vents, and not a whole lot to see. Okay? Now, the other thing that's neat about this power supply is the fan is designed to turn on when it needs to, which I like that because, like right now, I turned on my power supplies back here. Can you hear that? So, I hear fans. It's kind of loud. It's kind of annoying because I'm not using them. There's no loads on them, but yet they're sitting there blowing full blast. So it almost takes more heat to run the fans than they're doing it. They're just cooling themselves off for the heat they create. I don't know why they ever did it that way, but it was cheaper to do it that way, I guess. So, that's one thing, this little inexpensive. Now what I'm looking at is I'm looking at these rubber feet. They're pretty nice. You know what? I thought they'd just be like stuck on, but there's actually screws in there. That's actually impressive. A lot of these inexpensive devices, well, not just inexpensive ones, some of these expensive ones I have, they're not even screwed on. Some are not. And especially when you have a heavy duty unit and they're not, screwed on. Sure enough, that plastic's going to get knocked off. Something light like this, they could probably get away with it. Anyway, they're screwed on. What do you guys think? It looks kind of sexy, huh? Nice little black, sleek looking. Kaiweets. They make some nice meters. I've got a current probe that I reviewed. I'll put a link below on that. It's an AC current probe. They have an AC/DC current probe that I think they're going to, I think they've offered to send that to me. Now from there, you might be able to see there's 3 terminals on this. So there's a positive, a negative, and a ground. And what's nice is they actually offer the ground. I rarely use the grounds, if any time. These more expensive power supplies will have them. What you'll notice on a lot of the inexpensive power supplies, they don't have them. Now this thing, what it has, I'll show you a close-up of all this, of course. There's a shorting bar that shorts the negative to the ground. I usually move that or remove it because I want my output to be floating, okay? I don't want, you know, for one thing with the scope, it makes it a lot nicer when you have a floating output. It's like running off a battery. You don't have to worry about this being ground as far as earth ground. It's just a return, plus minus, okay? So I like that. And it's 30 volts. That's actually considered safe voltage. So yeah, got a nice display. I want to turn it on. You know what I really like about this is it has voltage, amps, and watts. So I want to see how that works. The other thing that I saw this power supply has, if you notice, there's some other ones on Amazon that are narrower. They're more this form factor instead of this wide form factor. Well, the thing you get with this one is you get both on your voltage and your current. You get a coarse adjustment and a fine adjustment. So this is more of a, supposedly it's a precision, you know, power supply. So we'll find out if that is. The fine one takes you, I think, up to 1.8 volts change from across the thing. So that's kind of nice. I mean, 1.8, sometimes they don't change enough. And if they change too much, then they're not fine enough, right? 1.8 is about 5% of the full range, you know, roughly. The current is 0.45 amps, so almost a half an amp range. On 10 amps, again, about 5%. So, I mean, roughly. And then also it has this USB output. And maybe that is to power things like my current probe. Like these little boxes. They come with USB. So maybe I can just plug that USB into this. It's 5 volts, 2 amps. That might be a use for that. So it's got this, they call it yeah, it's got this nice little rubber handle. It's so lightweight, but this rubber handle is pretty comfortable. And we got our fan, of course. Like I said, it's only supposed to turn on with power. We're going to find out how that works. And it has the fuse right here, so it's easy. You don't have to open it up. But you know what? Besides taking some measurements on this, we're also going to do a step load. So we're going to see the current to see when we all of a sudden go from, say, a very minimum current load to a high current load. We're going to see if the voltage, how the voltage reacts to that. Also, what some people don't think about is going from the heavy load to the light load. We're going to release the load, basically go from, you know, running pretty heavy, and then all of a sudden we'll take off the load, and we'll see how the output behaves on that. Sometimes a little bit overshoot or undershoot is okay, but we'll see how it behaves. Again, the CE mark, and I've heard some pretty funny comments about what that CE stands for, but it's supposed to be a safety mark and it's self-certified. What I see on this, when I'm looking around, I see 2 screws holding this plastic front end on here, and then I see 4 screws here, and from the back, you know, obviously the fan's being held on with 4 screws. The top screw up front to hold this plastic, screw here, and the corner's one here. So yeah, not an excessive number of screws, and I mean just enough, I think. And they are Phillips, so that'll make it easy to remove and to look in. So besides taking the measurements, we'll take a look-see inside. There is a quality sticker passed. Some people do, you know, take note of that. At least they feel like it's been tested if they see that. You know, whether or not that means anything to you, it's hard to say, but it's there. And you know what? These knobs, It's about a 1-turn knob. Yep, they're about, yep, just 1 turn, so you're not gonna have to sit there and, you know, spin them for a long time. Also, this guy gives a constant voltage or constant current. You can set it up either way. Other than that, it's not programmable. And yeah, well, okay, let's bring the camera over and take a look. Now, when I looked on Amazon, there's like almost 60 customers on this, and it had a 4.5 out of 5. So, you know, for Amazon, that's a pretty good rating, I think. And when I looked at the other power supplies, the inexpensive power supplies on Amazon, I didn't really see any that had like lots of customers. So, you know, that's not very many people buying it, or at least not many people reviewing it. If it's anything like YouTube, I've noticed it's only a small percentage that give thumbs up, you know, and so I would think that if there's 60 viewers, then that probably means there's probably 600, 6,000 people that have bought this thing, just if it's anything like YouTube. So, alright guys, I like the looks of it. I really like the 3 different displays. Let's power this bad boy up and take it for a spin, okay? Alright guys, so just go through the setup here. This lead right here is coming from the power supply, okay? And one of them goes through the arrow, the direction of the arrow, through the mixed sig current probe. That's this guy here, set times 10. And I did a review on him recently. Really nice probe. So what I have attached to that is an oscilloscope probe, okay? And also these 2 alligators coming from this lead, which comes to the FLIR, which I also reviewed. And then we'll use this thermal camera to look at the wires, see if it's getting hot, okay? That's the module there, the FLIR power supply. So yeah, everything's relative, so it'll look red even if it's not hot, just a few degrees hotter than room temperature in here. But oh, and then this capacitor, that's a 1 microfarad film cap. We'll probably use that later too. And this 200 watt 4 ohm resistor, we'll use this for some load testing. We want to use a nice quiet resistor. We don't want to use the active loads I have because they could have some noise, okay? So, alright, let's go look at the scope. What we're going to look at is the scope, the power supply, and this multimeter for most of the testing. Alright guys, what I've got is channel 1 looking at voltage, and I've got it right down here in this grid, and it's 5 volts per division, so we can go 5, 10, 15, 20, 25, 30. We'll be able to capture the whole voltage range. I've got the current on this grid on channel 3, and it's 2 amps per, so 2, 4, 6, 8, 10, so we can get, you know, that full range. And I've got measurements here on RMS, if you can see that maybe, and peak to peak on channel 1, and peak to peak on channel 2, and RMS on channel 2. Alright, and I put the current probe on times 100 because we're going to go over 10 amps, I think. I think we're ready to go. These are all set to minimum, and it's showing constant voltage right now and constant currents right here. So the course adjustments here, and right now the scope is 500 milliseconds per division, so it's going to go very slow, and that way you can watch me change the ranges, and you'll be able to see everything. Alright, let's first go ahead and just raise the voltage all the way up. Okay. These knobs, you know, loose or anything like that, they're really stable and they have a nice smooth feel. Okay, now it's 30 volts. Let me take the fine all the way up. Alright, so that looks like our max, right about 32 volts. And this meter, 32.011, pretty much agrees with that. So the full range scale looks like it's been kind of calibrated for that, because it looks like it's pretty much spot on. Now what I'm going to do, well, I'll tell you what, let's change this to 3.3 just to check that fine tune, see how easy it is to get to 3.3. Whoa. A lot of times power supplies have to kind of discharge themselves. Wow, I hit that right on without even hitting the fine. You know what, let's try 1.8. That's a low voltage, that might be hard to get. Whoops, okay. Okay. Try to dial in 1.80. Wow, that wasn't too bad. Now this says 1.81, so maybe on the low end scale, it's a little bit, just a little bit high. I think the tolerance is 1%. Alright, check the manual. It's 4 digits here on the end, so you could be 0.04 or plus or minus. A lot like a multimeter, that last digit doesn't count as much. Okay, so it looks like we're doing pretty well. Let me go ahead and put my resistor load on here, and we'll take up the load and see how high we can go. Okay, now that's the 4 ohms at 1.8. We don't have a lot of current on there, so let's go ahead and bring that current up, or bring the, oh look, it's enough current that I didn't have this set. You know, they're both set at pretty much 0. The fine was turned all the way up. Look at that, they're all 0. So if I turn the, and it says it's in constant current mode. So if I bring the current up, there we go. So if I bring it right up there, we could get our current out, okay? So, and look, there's some noise on that high frequency noise. Let me adjust the scale up for a moment here just to look at that. See that high frequency noise? That's 500 milliamps per division. That's about 1 volt peak to peak of noise. But you know, sometimes it's a setup and all that. It's a switching power supply, so the input filter will probably take care of this high energy spiky stuff. But let's just see if I go to my channel 3 and bandwidth and limit it to 20 meg. Yeah, see, that cleans up a lot of it right there. So a lot of that's really high frequency stuff. You know what, I have that one mic cap, right, that I showed you before. We'll see what we can do about the noise later on. But let's go ahead and bring up the current again by bringing the voltage up. And into 4 ohms, we'll see the current go up as well. See, we're at 2.8 amps. I gotta get my current scale down to 2 amps per division. Okay, there we go, 5 amps. Bring this all the way up. Okay, you know, we're not at 30 volts, right? Because look, we're in current limits, so I got to bring my current up. And this is how you can set your current level. What if I only wanted to be limited to 2 amps? I could drop this down to, you know, 2 amps. There's the fan just kicked on. Okay, see, I could set that current limit right there to basically 2 amps. That way, if I wanted to limit my current, that's how you do it. You know, essentially, you usually short the leads together. In this case, the 4 ohm load's just as good as a short when we got the voltage up to 30 volts. So we're only getting 8.4 out based on 2 amps and our 4 ohm load. So 4 ohm times 2 amps is 8 volts. So it looks like our 4 ohm load is a little bit higher than 8 volts. Well, actually, this says 8 volts here over here by our load. So I'm wondering if we're dropping that across the leads here. All right, after a little investigation, I found out my leads over here on my probe, my current lead was not making a good connection. So we're up at 8.3 almost, 8.29. This guy says 8.45. I've got my Habo test meter, which I think is actually a Kaiweets meter. I kind of forgot about that. So here, if I go right up here, 8.39. So yeah, it looks like that's 0.01 up maybe. And so it looks like we're dropping about 0.1 volt across both leads. You know, really remember the current has to go out and back. So that's about 30 something inches. So that's like 60 something inches of wire. 0.1. So that's not too bad for 2 volts, I guess, or 2 amps. Okay, I brought the meter over just to, and I also changed it to the Habo test, which, like I said, I think it's a Kaiweets meter. They have the same number, I believe, HT118A. And so I tried to squeeze in the picture, get a better picture of the scope here. It shows 8.22 volts here on the voltage, and let's see, current is 2.1. So yeah, pretty close to these readings. Let's go ahead and bring the current up higher, so we'll take it out of constant current and get a bunch of current going. Okay, so now we're up to that 32 volts, and look at that, 245 watts. Wow. Now if this is correct, which, yeah, and this is 31.38 volts, then we got about 0.6 volts, half a volt across our leads. They don't feel even warm to me. My resistor is going to get hot though. Okay guys, so what I'm going to do is I'm going to take another meter here. Okay, the Amazon meter says 31.86, and so it's only about 0.2 volts off. 31.34. So if it's 31.86 here and 31.34, so yeah, maybe about a half a volt we're dropping. Another thing I want to point out real quick, see this ground lug? I kind of loosened this knob. It's hard to rotate it past this lip unless you really loosen this. So I'm going to take that off and flip it around so that I can rotate it this way, and that way it's easy to latch into this if I ever want it, which probably won't, but you never know. And the nice thing is this is a pretty nice inset piece of brass or whatever it is in there, copper, brass, I'm not sure, but could be copper. I always suspect brass because it's cheaper, but you never know. This looks like a nice terminal here, and then it's, whoops. Alright guys, I was getting a little sparky there, so I thought I'd better remove it. Alright, so let's go put it back on this way. So it's nice that it comes all the way off though, right? Okay, now I can turn that back on. So now see, I can rotate this way, and I don't want to do it right now because I'll get a little spark. Yeah, I know the safer thing might be to remove that altogether, but if I did, then I'd probably lose it. Alright, now you might be able to hear that fan. It's still going because I just barely pulled the load off of it. And what I did is I set up the scope so that we can, in normal mode, trigger, and I've got the trigger level set at 2 amps right here, one grid above the line. So there's the trigger point right there in the center of the scope. So okay, so what we're going to do is I'm going to connect the load real quick, hopefully hold it there, and we're going to watch the current shoot up and see how fast it goes up, and we'll see if the voltage takes a dip. Okay, so we're triggering on the current right there. Okay, here it goes, and you'll see the current jump up here too. Now look, by the way, with no load, 32, there's no drop across the wires. Alright, here we go. Okay, I heard a little bit of an arc. See, the current jumped up. Look how fast. The current jumped up very fast. That's kind of cool. But look, there's no overshoot on the current. That is impressive. Let me zoom in on that. Wow, that was nice. I already had it set up. Look how nice that is. Okay, now this is, where's the time? 10 microseconds. So it came up within, I'd say, about 20 microseconds to full current value for that resistor. So it went up 2468, and man, that was fast and smooth, no overshoot. That's great, guys. Now look at the voltage. I don't even see the voltage dipping down. That seems almost too good. Let's try that again. Okay, I'm gonna hit the single trigger. We'll just leave that where it is and see if we get the same picture. Okay, ready? Ready, set, go. Takes a moment as I'm holding it. Wow, that's almost exactly the same picture. Yeah, I have to hold it there for a minute because it's, taking 5 seconds of information. That's a lot of data. But man, that's crazy good. Now let's look at this, okay? Because I'm going to do it one more time. And here, I'm going to hold it down. I'm going to touch it and hold it. Look at that. just sitting there pumping out almost 8 amps. I think, that time when I pushed to make the contact, I didn't do a very good job. You can see it over here, but over here, yeah, see that? It kind of moved from me, but man, look how, I mean, that's kind of an interesting jump just by accident. And look how nicely it's regulated, the output. That's impressive, guys. Okay, the other thing, I'm going to go ahead and connect the load, and I'll turn the trigger all the way right below the max value there, and then I'll release it to see if, on a release mode, if the voltage bounces up, because that's also sometimes a tough thing for a power supply. It's part of the control loop thing. Okay, I'm pulling the current, and I'm going to let go. Man. Oh, yeah, you have to wait, huh? Wasn't being patient. Okay, so it started to fall off, and then I guess it doesn't fall off as fast. Let's zoom out. There we go. It started to fall off. That could have been me too, not pulling it off real smoothly. I need a knife switch so I can open and close contacts quickly. And so there we go. Here, I'll try that again. Okay, we're drawing current. You can see it over there. I just heard the power supply go back on. Whoops, it triggered on the rising edge. Okay, ready? I think I got a quick release that time. Man, yeah, still not too great. You know what? That guy right there, we could probably calculate the output capacitance of this power supply based on that. You know, the 4 ohms discharging the current pretty linearly, but then it switched off right there, so I'm not sure about that. We're going to try it one more time. Okay, here we go. It's drawing 7.68 amps. Okay, set the trigger. It says pre-trigger. Okay, question mark's ready, so it's ready for us to go. It says it triggered. And there it goes. Yeah, it's interesting. This is me, but then look at that. But look at the voltage. It kind of slowly kind of rises, but I think that's just because the internal, you know, the IR drops. It's dropping less voltage, so it kind of floats up to what it should be versus here. Let me hold the current down. So we're dropping about a half a volt across the line, and this is more not the regulation of the power supply going up, but see, this is steady, so it's more of this. When I let go, this kind of floats back up, and so I think that's what this is. That's just that we stop dropping the voltage across the wire. So yeah, actually that power supply looks pretty darn good. I mean, it's the control loop inside the switcher is working pretty well. Okay guys, so what we want to look is the ripple on the output, and look at this. This is 500 millivolts per, and it's pretty bad. Peak to peak, it's about 500 millivolts, and it's 25 millivolts RMS. So that's a lot of noise, and we only have just a little bit of voltage coming out. Okay, it's just a switching power supply noise, but I think we can fix that. Here, first of all, let me show you how bad it can get. If we go up to full voltage, I've got it AC coupled. Alright, so full load, look at all that noise. Half a volt, we got about 1.5 volts peak to peak. Okay, now remember this capacitor, this 1 microfarad poly cap? Okay, I'm going to put it right on the load. Watch what happens. Look how that cleans up, just 1 microfarad capacitor. That's not bad, huh? Alright guys, we're doing the thermo test. I'm running full current, 10.5 amps through the test leads, and I can feel the copper inside is pretty hot. But I can touch leads, but I wouldn't want to hold them too long, probably. So we've got 9.37 watts being dropped across the leads, 0.89 volts, and 10.53 amps. Now, you know, as heat goes, as copper gets hot, or as wire gets hot, it's going to increase in resistance. Well, I haven't seen the voltage drop change too much since I've started this about 5 minutes ago, and it kind of seemed like it stabilized. It got hot in the first couple minutes, And as a matter of fact, the fan on the power supply kicked on in about 90 seconds into the test. So here's my thermal camera looking at it. Alright guys, you can see the hot spot up in the top left corner. I'll tell you what, once you get over 60C or even 60C, you don't really want to hold them too long. And as I move that around a little bit, you see that pointer, it'll find some pretty hot spots. Like 71C, 73C right there. See the center of the screen? I've kind of got a, see that center right there? I kind of got a marker I can put where I want to, so I'm putting it on the white part, which is the hottest part. See 70C. But I can touch it, which if that was over 60, if that was 70C, I wouldn't be able to do this. So it's got to be reading the temperature of the actual wire inside the rubber. I think that's really cool. Anyway, if you're going to run 10 amps, I suggest getting bigger leads. But, you know, it's nice they gave you some to come with it, I guess. But I would go with bigger leads. The other thing about this, remember, whenever you short the leads, that's how you adjust the output current. So if you want to current limit your power supply before you start testing something, short them, set the current limit, and then you're away to go. The other thing I do want to point out about this is that 5 volt 2 amp output for the USB. So that's nice. You can power up your USB devices like differential probes, current probes, whatever, with this if you need to, or charge your thermal camera. Alright, well, I guess we can look at the power going into this. It's 4.4 watts just sitting there, pretty efficient. The current's 0.074 amps. It's 60 hertz and phase is about 0.5 power factor. Not great at all, but 5 watts, who cares? And the voltage is 119.5 volts. Okay, 4.4. Let's go ahead and bring up the current all the way in. Let's load this thing down and see what happens. Okay, we got that 10.5 amps back. And we're 8 watts here in our leads. And it's 35 watts. Okay, we got almost a half an amp going in. And look, power factor is 0.63. So that's about right. Half an amp, 120 volts, is about 60 watts, but we're not doing 60 watts because that'd be the apparent power. The real power was only, see there's 119.5 volts. The real power is only about 40 watts. So that's that power factor. So it actually has to pull in about 60 watts to put out 40 watts because of the power factor. That's a linear power supply on the front end, it sounds like, which is kind of odd. It doesn't have power factor correction, but then it goes to a switching power supply to supply the output. Alright guys, I've taken the screws out of this. There's 3 on each side. And from this angle you can see the board's right down here at the bottom. A lot of airflow on top, and there's 2 screws on top. It fits kind of snug. Alright, there we go. There's the board. Okay, we're focused. Alright, power comes in here, and it feels like those are soldered on with heat shrink. That's nice. Okay, the ground wire is this white one. And it looks like it wraps up. See this mounting post here? This screw, it looks like it's fitted underneath that, so that's good. So it goes right to the chassis like it should. Alright, and then the other wire, the yellow one goes to the board. The black one takes off and comes up to the switch up here, and then comes back on this yellow one right here. There's a poly cap down inside there, big poly. Let's look on the other side. I thought I saw some part. Okay, there's some big old ceramic resistors. And then there's the red and black wire right here. Okay, this is the output of the main output, because I can see those wires coming up to this, okay, coming up to this little board right here, which is our terminal post. And there's a nice aluminum cap. Looks like it's 160 volt. Wow, that's plenty of voltage for that output since it's only 30 volts. And it's 47 microfarads and 105C rated cap. So that's nice. Those bolts are, it's bolted onto the board, so that's very solid. Big old solder on the black and red leads. Okay, and then here's our board holding our pots. That's nice. Feels very solid. And then here, let me zoom in on that. Can you see that? It says voltage, current, and watts. So that's just the meters on front, so you can calibrate those if you like. Now look at all these connectors. They're all put on with this some kind of epoxy. So I'm not going to be pulling that apart, guys. Yeah, they're all that way. Okay, let's take a look at this power supply. Alright, what we see is Emi filter, obviously up here where the power comes in. Now here's a big old PTC, or NTC, sorry, negative temperature coefficient. It's I don't know if you can see that. It's a 10D-20, so I guess that's 20 millimeter. God, it's a big thick one, and it's 10 ohms. So it starts off 10 ohms and drops as current starts to go through. And then our EMI filter, our combo choke with our 2 X capacitors, poly caps, and then our blue ceramic capacitors for a Y, and then a big old bridge rectifier there. Alright, and that's a KBU 810. Look over here. See that guy right there? That's a current sense transformer. So we got our wire going to that. That's a nice touch. Those aren't cheap. Alright, so what happens is it looks like power comes in, goes through our current sense transformer over to our main transformer, switching transformer. This looks like a PQ core, which, see, it's a tall core. This is actually one of the more expensive cores, and it's optimized for winding area because it's got a long window, lots of winding, get really good coupling to the core. Plus it's fairly tight magnetically, so it's good for EMI, and it also has lots of surface area for temperature. Here's our big bulk capacitors, 560 microfarads. Kind of hard to see that because it's coming down the strip here. 560 microfarads, 200 volt. Again, 105C rated caps. There's a big resistors. That looks like a 3 watt, 5 watt maybe, and a couple of 2 watts down there. They must be, some of those caps must be to balance and maybe discharge these. Alright, so we have some slots in the board for isolation. So input voltage comes through our EMI filter, comes through our big bulk capacitors for our main power supply. This looks like it has several power supplies going on. I can see a bridge rectifier right here and some bulk caps. So another DC conversion right here, and then a little, that's the control chip for the switcher, and there's an opto for the feedback. So the output must be on this side with the big old bulk capacitor, and it's feeding this, so it's going up to our panel, so it's feeding that power. And then this looks like a coupled inductor off this main transformer, probably to supply a couple voltages, or at least a few voltages here for these cables, which also go up to the front panel. So I suppose those are, so we got several voltages going on here. And then our main output is this guy right here. So we have a nice toroid, nice sized toroid. See that? And that black core, that's one of the nicer cores. The green one's a step down, but still nice. The yellow cores are the real cheapy ones. So then we have, looks like a drum core here in heat shrink. And so that must be the LC filter output. This is a common mode choke. It's interesting, they used actually 2 different colors of magnetic wire. So yeah, and then there's a white or a ceramic capacitor on the output of that combo choke, and then this big old diode. That might be for reverse voltage protection on the output. And then it looks like right there the terminals are the wires that go up to this board up here. Whoops, knocked over the resistor there. So this is an op amp, and this is all the logic, all the regulation circuit. And then here's another power supply. Bridge rectifier right here. It looks like an Emi filter, maybe even. There's a fuse, so it probably goes in here through the fuse into this circuit. And some film caps. All these green guys are film caps. Bunch of film caps in here, and all the aluminum here's a little inductor. Here's an LC filter on the output. So this goes up to this red and blue wire go up to the USB port on the front. So that's our 10 watt, 5 volt 2 amp USB port. So that's that power supply. So it looks like there's like 3 switching power supplies in here. Alright. Wow, pretty cool. I think it's nice. The fan's mounted nicely. Everything looks like it's solid. It's a nice construction, I think. Solder joints all look really nice. It looks clean. Oh, here's some current shunts for the output. So for 10 amps, I guess they're using these big current shunts. Those are in parallel. I can see the pads down there. There's a close-up of the board. And then look at these big tall heat sinks. Those are tall, and those are rigidly mounted. You know what I noticed? Okay, these are the switching transistor, I'm sure, because they're right next to the transformer. And this is the output diode, relating to the circuit here. That's what it looks like. But you notice down there, there's a thermistor mounted to this heat sink and one mounted to this heat sink. So they're probably using at least one of them to turn on the fan, and which is right in front of the fan. And then the look at that, the heat sinks are, the fan's going to blow right into those heat sinks. So that's actually a nice design. Then the vents are on the side of the box, so the air is going to be pushed in and then pushed over to the sides. So it looks like the larger heat conducting parts, these resistors, are all mounted towards the side for that airflow, to get maximum airflow, I would think. And this trim pot right here next to the current sense, I would think he's to adjust for the current output. And this pot over here is probably for voltage. And here's our little fuse compartment for our input fuse. And the fan guard, nice solid metal fan guard. And our front face plate. Alright guys, so hey, what do you think of this? Kaiweets. Pretty cool. 30 volts, 10 amps, 300 watts. That's a lot of power. It comes out to about 30 cents a watt. The big brand names, they go for probably, I want to say around $10 a watt. Pretty expensive. Power supplies are just expensive. And then shipping costs too, right? Because usually the expensive guys are all heavy too. Although they do make switchers too. But still, they're expensive, and they're probably even more expensive. Now the Siglents, Rigals, they're a lot more affordable. They're probably $5, maybe $3 a watt. But 30 cents a watt, it's really hard to hate on it. I think adding, if anything, just adding a film cap to take some high frequency noise off this, soldering those on the input, I think I'll do that. And this guy should be good to go. I might want to get another one to put them side by side, so when I'm doing a lot of audio stuff I'm doing, or where I need a split power supply, I want to go above 3 amps, and this guy's limited to 3 amps, 30 volts a side, 3 amps a side, so that's only 180 watts total, 300 watts. There's just no comparison, I don't think. Geez. I'm just trying to think, how to hate on this thing. It's kind of hard to do it at the price. It's pretty unbelievable that you can get something that operates this well for $100. You might pay close to that for a soldering iron. and it's just got a little power supply to heat up a pencil. So you know, they're 30 watts, right? 300 watts. Yeah, I think when you start thinking about it, you're getting a lot for your money here. So hey guys, thanks for watching. I appreciate it, supporting the channel. Appreciate the patrons. It's awesome. And anybody wants to do that, there's a link down below for the Patreon. It's like $1 a month if you want. But I appreciate all the support, and thanks for your comments. Give me comments on these power supply videos. I got to improve on these too. But hey, we'll see you guys next time. All right, thanks.